Hello, I am recording this video to explain a question which was featured in the calculus end of topic test for Year 12 Calculus 2020, and it was quite well. I think it was just a really crap question because I didn't like it, and I had to. Well, it actually made me make my brain hurt, and usually that doesn't always happen with maths, but this one was especially difficult. It was making me think for the last 2 weeks about why it took me so long to solve. But now hopefully I can explain this question well enough in case you do come across a question like this in future tests, or if you decide to take a course or to take a path towards a very mathsy career. Yeah, so I'll be explaining this question now. Okay, so the question is question 2c in the test. Show that the curve y equals x to the power of 3, or x cubed take away x squared divided by 2 has a tangent line 10x take away 14, if you can't see that. And what you do is that you're meant to, what they want you to do, well, what I would do first is that I would differentiate the function that they've given us. So we know that fx equals x cubed take away x squared divided by 2. So that means that f prime of x equals 3x squared take away x. Now, I've used the power rule to differentiate this. That's the only way you should be differentiating this, otherwise you're being dumb. So I'm not going to explain the power rule at the moment because that's kind of a long and tedious explanation. I want this to be quick and snappy, which it probably won't be, but I'm going to try. Okay, so what you're going to do is you're going to set this function to equal 10. So you're going to end up with 10 equals 3x squared take away x. Then you're going to take away 10 because we're going to turn this into a quadratic equation. So we end up being 0 equals 3x squared take away x take away 10. Now we're going to factorize this. Now there are ways so you can factorize this in like a few different ways, but my favorite way is using the polynomial solver in the calculator, which you should know how to use. And but I'll just do it by hand because my calculator's being weird at the moment. So okay, so if 0 equals 3x squared, so okay, 3x squared, and then you're going to have take away 10. So we want numbers which add to negative 30, because we're going to times this by negative 30, negative times the coefficient of x squared by negative 10, and that should give us negative 30. And we want a number that times to that, and then we want a number that adds to up to 1, negative 1. Cool. There are multiple different numbers that do this, and this is actually what a lot of people get stuck on when they're factorizing numbers. I think it's really easy, but it depends how strong you are at maths. So just list them if this works for anybody. So just list the numbers to negative 15, 3, negative 10, 5 and negative 6. Yeah, I like those. Those are good numbers. So that'll be negative 6x plus 5x take away 10. Now what we can do is we can factorize this by being winner. So you can factorize it by separating these two individual parts of the our expression, and so we're going to have 3x, x take away 3, because 2, not 3, I'm being a winner. So x take away 2, because multiply that to get 3x squared, and multiply that to get 6x. And then for this side, we're going to have 5 times x take away 2 as well. Now, see, you'll know you're correct with this method because you've got this factor here. So if you've got this factor here on both sides, then you're nice and good, because you want this to be the same here for this one, and you want it to be the same here for this one. And if you expand that, you should get this answer, which is my answer, which is the correct one. Okay, cool. So that factorizes to 3x plus 5. X take away 2. I should probably put a plus in front of that 5, but you should know it's a positive. Okay, anyway, sorry for that long explanation. We will now solve it, because it equals 0. So we already know that if an individual factor on this side of the equation equals to 0, then the whole expression is going to equal 0, because 0 times anything equals 0, because 0 is a great number. So if 3x plus 5 equals 0, then x will equal 5 divided by 3. Understand? Yes. Then if x take away 2 equals 0, then x equals 2. So for this specific question, which is to show that the curve show that the curve y equals blah has a tangent line 10x plus 14, which can be shown as our lovely equation for a line, which is y equals mx plus b. So y stands for our y, and then m is the gradient, and then x and b. Yeah, so you should remember this equation from last year, level 1. Okay, cool. So let's continue. Because this is a negative number, here x equals negative 5 over 3. I don't quite like this one here. I don't know, it just doesn't work. I don't think this would work. You can test and check this, but I just don't like it. So I'm going to go with this one here. X equals 2. So that would mean that we can solve to find our y. So that would give us, so what we could do is substitute our value of x into the equation y equals x to the power of 3 take away x squared divided by 2. So then we have winner music. Y equals 2 to the power of 3 take away 2 to the power of 2 divided by 2, which simplifies to 8 take away 2, which equals 6. And that would mean y equals 6. And that would mean our coordinates would be 2, 6. Cool. Good. Yes, that makes sense. Now we'll move on, and we're going to substitute our new values into y equals mx plus b. Because what the question's asking us is to prove that there is a gradient of 10, because the coefficient of x is 10 in this original equation for the tangent line, which is, well, this represents a tangent line, and prove that b equals negative 14. So that's what we're going to do. And yes, so we know that y equals 6, and then we know that m equals 10, and then we know that x equals 2, and we want to know what B is. Honestly, you could just punch this into your calculator, but I'm not going to do that because I want to flex my epic math skills. So 6 equals 10 times 2, 20, 6 equals 20 plus B, and then take away 20. Negative 14 equals B. So B equals negative 14. Now, since we've got our known values, so Y equals 6, the gradient equals 10, and the X equals 2, and we've just found B by solving this equation. That means that the stupid tangent line that this question gave us is actually in fact true. So what would happen is that yes, 10x take away 14 is true, because we've just found that B does in fact equal negative 14, and yeah, that's right, which equals Y. And yes, which, yeah, that's right, good. Yeah, that's right. I'm sorry, I probably could have definitely could have explained that question much better. It's just I can't right now, and but this is how I did it in the test, and I'm pretty sure that's how I did it. I don't remember. I don't have my test paper with me at the moment. I just remember this question because it's been really annoying me that I don't understand it completely. But yeah, I said I've never come across a proof question as obscure as this. Maybe you don't think it's obscure if you're really clever at maths, but for someone who is also clever, no, okay, really not. Well, thank you if you did watch this whole video. Goodbye.